Today I want to have a look at an old Math Olympiad competition problem. It says we have three positive numbers, a, b, and c, and we want to show that the left-hand side, a over square root of a squared plus 8bc plus b over square root of b squared plus 8ac over c plus c over square root of c squared plus 8ab is greater than or equal to 1. So not only do we have roots here, but also fractions here. Like most Math Olympiad questions, inequality problems will involve. And we want to get rid of the roots and fractions in some way. So in one way is we want to introduce a parameter t that makes a over square root of a squared plus 8bc greater than or equal to a to the power of t over a to the power of t plus b to the power of t plus c to the power of t. Likewise, b over square root of b squared plus 8ac greater than or equal to b to the power of t over a to the t plus b to the t plus c to the t. C over square root of c squared plus 8ab greater than or equal to c to the t over a to the t plus b to the t plus c to the t. Because if that's true for some fixed value of t, then we have the sum of the right-hand side, that is a to the t plus b to the t plus c to the t, which is exactly equal to the denominator. That is 1. Then we're done. So if this is true, I'm just going to prove the first inequality, because the second and third are very similar. So equivalently, you have this multiplied by that is greater than or equal to this multiplied by that. A times a to the t plus b to the t plus c to the t is greater than or equal to a to the t times square root of a squared plus 8bc. And when you divide this a over here, then you have a to the t minus 1. And if you square both sides, so because both sides are positive, obviously, right? So then you have a polynomial expansion, similar to binomial expansion. Right? Just quickly, a to the 2t plus b to the 2t plus c to the 2t, just twice of a to the t, b to the t plus 2 times a to the t, c to the t plus 2 times b to the t, c to the t greater than or equal to a to the 2t minus 2 times a squared plus 8bc, if this is true. So when you multiply this, a to the 2t minus 2 plus 2, you have a to the power of 2t, same as this one. So we can simply cancel this one now. And what we're left with is just this multiplied by that. So greater than 8 times this times bc, if this is true. But before we even discuss this, we're going to loosen the left-hand side a little bit. For example, those two terms. First of all, greater than or equal to using AMGM inequality. It's always 2 times square root of the product of those two. So 2 times square root of, square root can cancel with this 2 and this 2. So b to the t, c to the t. And then when you have a look at this b to the t, c to the t, right, this term, just combine them 4 times. And when you look at those two terms, right, first of all, you have a common factor, 2a to the power of t. And then you have b to the t plus c to the t. Again, AMGM inequality, right, keeping 2 times at, right, twice of square root of, so 4 times square root of bt times ct. So b to the half t times c to the half t. And is this part greater than or equal to this part? We don't know. But we can somehow loosen it again using AMGM inequality. So it's always greater than or equal to 2 times square root of this time. So 16 times a to the t, b to the t plus half t, 3t over 2. Right, if I'm correct. C, likewise, 3t over 2. Right? So that is 8 times a to the half t, b to the 3t over 4, c to the 3t over 4. So we're talking about, is this greater than or equal to this? Right? So if you want to 8 times a to the 2t minus 2 times bc. Right? So you cancel out the a. And if you divide this over here, so a to the, first of all, change this sign. So 2 minus 2t plus half t. 2t, 2 half t minus 2t. So negative 3t over 2. And then you move this term to the other side. So is it greater than or equal to b to the 1 minus 3t over 2 times c to the 1 minus 3t over 4. So what kind of t can satisfy this inequality? We don't know. We don't know which one's bigger. All we know is that they're all positive. Right? So t equals some random number. We don't know if it's true, but if we consider the special case, right, if we turn this power into 0, right, when t equals 4 over 3, yes, 4 over 3, becomes 1, becomes 0. This becomes 4 over 3 times 3 over 2. That's 2. Power becomes 0. Right, maybe that's true. Right, a to 0, 1 greater than or equal to 1 times 1. So it doesn't have to be strict inequality. Equal sign is also fine. Right? This is a non-strict inequality when t equals, like I said, 4 over 3. Right? So this equal sign holds. Right? So when this equal sign holds, so no matter what t is equal to, right, this inequality is always true. Left-hand side is always greater than this part, greater than or equal to this part. Right, AMGM inequality, this is always true. This is always true. AMGM inequality. Right, so this is equal, this is equal. Right, this equals. So when you have the left-hand side, it's greater than or equal to this part, greater than or equal to this part, which is equal to this part. Right, so this part is this part. So in the end, left-hand side is greater than or equal to this part. Right? When t equals 4 over 3. So yes, when you have t equals 4 over 3, you have all of, first of all, you have this inequality holds. Likewise, like I said, I'm not going to prove those two because they're quite similar. Then you have the right-hand side add up to 1. Then we're done.